Hello friends, welcome to our channel. Let's have a look at problem 3105, longest strictly increasing or strictly decreasing subarray. So here we are given an array of integers called nums. So we want to return the length of the longest subarray of nums, which is either strictly increasing or strictly decreasing. So there are 2 points to be noticed in this problem. One is the sequence should be either strictly increasing or strictly decreasing. Strictly, this is the one thing. And the other point is that we need to pay attention to the fact that we are considering subarray here. So actually this subarray assumption makes this problem very easy, right? Because subarray should be contiguous. So if you look at the 3 examples, you can easily interpret. So for example, example 2, so this is the one due to the strictly assumption. And in example 2, you can get 1, 3, 1, 4, or you can get 4, 3, right? So all 3, 2. And these are length 2. So in the example 3, because this is strictly decreasing, so you are going to return 3. And also the problem size is very small, because the length is bounded above by 50, right? So with that said, let's look at the coding. So here I'm going to use something sort of like dynamic programming, but I guess we don't need to term it as dynamic programming even. So here I'm going to first get the length of this nums, and then I'm going to define 2 arrays. One is called increment, so this is 1 times n. And the dic also write 1 times n. So here inc I means the longest increasing, strictly increasing, right? Strictly increasing subarray ending, let me put it this that, ending at index I, right? So similarly, you can interpret dic. It means that dic I means the longest strictly decreasing subarray ending at index I. Then finally, we just need to return the max of this array as the max of this 2, the larger of the 2, I would say. So then we just need to do a linear traversal. So for I in range 1 to n. The reason I start from 1 because I want to compare with the previous one. Because if you at the start, so you always the length is 1, right? So then first we are going to check if nums I is strictly larger than nums I minus 1. So in this case, so we're going to set inc I equals inc I minus 1 plus 1, right? So similarly, you can check nums I is strictly less than nums I minus 1. So it means this is decreasing. So dic I equals dic I minus 1 plus 1, right? So what we want to return is nothing but the max of this inc and max of this dic. So let me first do a test and then make some comments. Yeah, it passes the 3 cases. If you submit, it passes all the cases. So this is the one, this is the full code. Now let me give 2 comments. First is that here in this one, for sure the temp complexity is O of n. And the space complexity here is also O(n). But you know, the first question is, can you modify the code to make a O1 space solution? I guess this is very straightforward, right? You just need to introduce 2 running variables or more, yeah. At most 4 if you like. So this is the one comment. Another comment is that in this problem, we are talking about subarrays. So what about subsequence? So if we change subarray to subsequence, so in other words, subsequence is not necessary to be contiguous for elements from this original array. So can you solve the same problem using sub O(n) square time complexity solution? Algorithm. Let's see. Algorithm. Yeah. I guess here for pedagogical purpose, so we used ink and dig. So this is very easy to digest, right? So now you can try to use some running variables. So this is the one very straightforward one. I would say for the first one. Well, for the second one, it's rather straightforward to get a square time complexity solution. But if you think a little bit, you can actually get sub(n) square time complexity solution or algorithm. So with that said, I guess that's it for the current video. Thank you for watching.